A college student in Mexico City uses a Lisp program to develop techniques of language translation, while a programmer in Santa Monica, California, debugs a graphic output formatting program. And in the Pentagon, a user retrieves information from a database by means of an online query system. These users, widely separated by geography and purpose, have one thing in common. They and more than 24 others are independently using the same computer at the same time. Each is linked by phone lines to a general-purpose computer located at the System Development Corporation in Santa Monica. This experimental general-purpose time-sharing system was developed by SDC under contract to the Advanced Research Projects Agency. There are 450 independent authorized users, but only 30 can have access to the system at any one time. Moreover, as with all computer systems, storage space is limited. To the users, this means problems in first gaining access to the system, and then keeping their drum or disk space. To the system designers, assuring enough storage space for all potential users is not merely a matter of building still larger machines. An increase of system capacity would inevitably be surpassed by an increase in demand. The basic problem is one of system management, deciding on the best balance between system resources and user needs. The man who must live with the day-to-day job of assigning or removing from the system any of its many users is the system operator. A set of management tools has been developed to aid him in this task. These tools, together with the operator's human judgment, are a new and important part of the management of a time-sharing system. The operational nucleus of the time-sharing system is the Research and Technology Laboratory and its AN-FSQ32 computer. The Q32 data storage, operating on a 48-bit word, includes a 65,000-word core, a 4 million word disk file, 700,000 words on drums. 16 tape drives complete the basic configuration. A major peripheral component, the PDP-1 computer, controls real-time inputs and outputs. The online input-output units available to users within the lab are display consoles and teletypewriters. Remote users are linked by teletypewriter exchange and data phone. Managing this system is a complex task. It requires scheduling time for each user, implementing priorities, deciding which users must be terminated to provide drum or disk space for other scheduled or higher priority users, and allocating storage to the oncoming users. To assist the operator in implementing these decisions, he is provided with the capability to communicate with system users, a guaranteed access schedule, and a computer program, the manager program, which generates displays to help him determine up-to-the-minute system status. The blanking effect seen here is due to the photography and is not normally apparent. The operator's teletypewriter permits communication with all users through an executive system command known as dial. For example, the user can ask the operator for help on procedural problems, or the operator can inform a user of termination time. The operator can also communicate with all users at the same time, giving them timely messages, such as last-minute schedule changes. The system is heavily used and overloads are frequent. To improve service, a guaranteed access schedule was developed. This schedule is based on requirements of various high-priority online projects for drum space, disk storage, and computer time. The schedule guarantees the user a channel and normal storage requirements for a certain period of time. A project on channel 2, for example, is guaranteed drum space of 47,000 words from 7:30 to 8:30 hours. To promote maximum use of the system, Unscheduled users are allowed access when space is available. This access is not guaranteed, and the users generally have small programs to run. The larger their program, the greater the chance that their space will be usurped by a scheduled or high-priority user. In order to determine which non-scheduled or low-priority users are to be terminated to provide the needed space, the operator can call up a number of displays generated by the manager program. The manager program processes system data in real time and displays it on the operator's console. Two types of displays can be generated. A channel-oriented display, which is normally present and periodically updated, and a set of disk storage displays, called up by light pen action from the channel display. In the channel display, the listing for each currently active channel gives the program name and size, the assigned drum, the user's job number, preceded by a priority number, the requested tape number, and the operational status of the program. The upper right portion of the display lists the tape drives for each channel. The channel display also shows availability of disc tracks, tapes, drum space, the time, the number of users logged in at teletype stations, and the number of users who have logged in and loaded programs. An operator wanting a more detailed display for a channel can type the channel number to the manager program. The program then places in the lower right corner of the display certain system parameter values, which indicate the user's operational status, his elapsed time since start, his total compute time, and the time since he last took action. Across the bottom of the display are two rows of alphanumeric characters. By taking light pen action on any character, the operator can call up a list of all files beginning with the letter or number selected. From the beginning of the system, available disk space steadily decreased. Originally, programs or data stored on the disk and not used during a consecutive 2-day period were purged. In time, this period was reduced to 1 day, and on-the-spot deletions by the operator became necessary. If an operator notices on the channel display that the number of available disk tracks is critically low, or if a user asks for more space, the operator can call up by light pen one of 3 disk storage displays to determine which disk files to delete or to unload onto tape backup. The first disk display contains the disk inventory name, along with the user's identification number, the number of tracks he is using, file type, such as binary, the file status, either active or inactive, the date last read or written, and a numerical code indicating whether the system has automatically transferred the file to tape backup. From this display, the operator can delete files from the disk inventory or unload them onto backup tape by triggering the dot preceding the file name. The file name is then displayed to make sure an aiming error was not made with the light pen initially. When final action is taken, an updated version of the display is returned to the screen. The second kind of disk display is used when the operator wants to inventory the disk storage in terms of file size. It is similar to the first disk storage display, except that it lists the 27 largest files in order of the number of tracks assigned to each file. The third disk display enables the operator to scan large segments of the disk rapidly. It shows the file name and number of tracks for each file, for as many as 54 files. These, then, are the basic displays generated by the manager program. The channel display, which gives an overall picture of user activity, and the 3 detailed disk storage displays, which allow the operator to quickly scan the disk contents, to delete files, or to obtain additional data about the files. In the day-to-day operation of the SDC time-sharing system, we will see how the manager program helps the operator resolve the problems of insufficient space for programs and data. This user has been guaranteed computer time, but cannot begin because there is not enough drum space for his 43,000-word program. Since this user has been guaranteed access, The operator must now determine which non-scheduled users he must terminate. He checks his channel display. Because the program must be loaded onto a single drum, he checks which of the drums has the most word space available. Drum 2 has space for 18,809 words. This means that in addition, more than 24,000 words will be needed from the users on drum 2. The operator picks out those users on drum 2 who are not scheduled. The pint program on channel 40, less than 20,000 words, low priority 5. On channel 46, the program also is unscheduled, using about 5,900 words, but it is a high priority user. Channel 38, however, is low priority and occupies more than 7,000 words. The totals of channels 40 and 38, plus the space already available on the drum, are enough for the eligible user to load his program. The users are notified and are given time to wrap up their work. In some cases, when extra time is needed, the operator adds human judgment in implementing the scheduling process. Actually, there is now a surplus of nearly 3,000 words available on drum 2, enabling some non-scheduled user with a small program to enter the system. In the second example, the problem is to obtain disk space. This user needs 120 disk tracks for a large database. Only 3 are unassigned, but an additional 97 are available since they are on both disk and tape. A total of 100 tracks can therefore be immediately assigned to the user. The operator will have to reclaim an additional 20 tracks to meet the user's requirements. In this display, there are files that use a small number of tracks, so it would be quicker and more efficient to look at a list of files with the largest number of tracks. File name Meta01 has 12 tracks. It is a program file. It is inactive, more than a day old, and it is on disk only. It is deleted from disk and unloaded onto backup tape. The operator must now find and delete enough tracks of similar status to obtain the required total. The new user is now assured of his needed disk space. The manager program and its set of console displays are an approach to the solution of operational management problems in the SDC experimental time-sharing system. These and other techniques under development provide a basis for expanding the usefulness of time-sharing and are furnishing insights into the management of other computer-based systems.